In this video, that will be a live solving of the GCSE Mathematics AQA Paper 1 non-calculator from 2019, and this is the foundation tier. So through this video we will solve the questions live, and we'll go through exactly the thinking behind how you should approach these questions and solve them. If you have any questions, please let me know and I will happily answer them. So the first question we've got is, what type of angle is the largest? And you're given 4 answers to go through. The first one is a right angle. This one is 90 degrees. We have a reflex angle, and a reflex angle is an angle that is greater than 180 degrees. So something like this, for example, where you're measuring this part of the angle. So this is always greater than 180 degrees. Remember, 180 is the angle of a straight line. An obtuse angle is an angle that is greater than 90 degrees but less than 180. So somewhere between these two lines here. And an acute angle is an angle that is less than 90 degrees. So the biggest angle is obviously the angle that is greater than 180, and that is a reflex angle. Question 2, solve 4x equals 8. So this can be written as 4 times x is equal to 8. And to remove the 4 over, you need to divide both sides by 4. So if you divide the left hand side by 4, you end up with x. And if you divide the right hand side by 4, you end up with 8 over 4. 8 over 4 is equal to 2, because 4 times 2 is 8. So therefore x is equal to 2. 10 plus minus 4. So what we want to do here is expand out the brackets, get rid of these brackets. So this is the same as 10 plus minus 4, which is 10 minus 4. Remember, adding a negative turns that into a negative. So we've got 10 minus 4, which is equal to 6. The next question we have is circle the calculation, which works out to a half of 12. So the first one, 12 divided by 0.5, well, this is the same as 12 divided by a half, which is equal to 12 times 2. So whenever you divide by a decimal, you are essentially making that number bigger. So in this case, this is not a half of 12, so 12 divided by a half would actually give you 12, is the same as 12 times 2. 2 divided by 12 is not equal to half of 12. This 2 over 12 we can simplify down by dividing both sides by 2, which equals 1 over 6. We've got 12 times a half, which is going to be the answer. 12 times a half is equal to 12 over 2, because we could just say 12 times 1, which gives us 12, and then divide that by 2, which equals 6. So this is our answer. The final one is 12 divided by 50 times 100, will not give us anywhere close to our answer. The next one we've got is a sum, 364.5 plus 17.9 minus 2.08. So there are lots of ways to solve this one. The way that I always prefer to do it is to use the following method. So 364.5 plus 17.9. And you can take this step by step. There's no reason to rush this and do everything immediately. So we could do the first addition here. And simply we just use the following method. We do 5 plus 9. If we do 5 plus 9, we get 14. So we have 4, and then we have a remainder of 1, which carries over to our 1's column. Then we do 4 plus 7 plus 1 here. So that's the same as 4 plus 8, which is 12. So we've used our 1 up here. We put a 2 here, and we carry a 1 over to our 10's column. Then we do 6 plus 1 plus 1, which is the same as 6 plus 2, which is equal to 8. And then we've got 3 here, so 382.4. Then the next step is then we need to subtract away 2.08. So please don't forget to do this step. So 302.4, subtract away 2.08. Now notice here that you've got more decimal places so than you have in 382.4. So we need to add a 0 in here. When you subtract, you need to start from the left hand side. So we've got here, sorry, from the right hand side, so we've got 0 minus 8, so we need to steal one here, and then we have 10 minus 8, which is 2. 3 minus 0 is 0. 2 minus 2 is 0. And then here we can add a 0 and a 0. So 8 minus 0 here is 8. And 3 minus 0 is 3. So we end up with our final answer of 380.32. The next question we've got is 9.36 times 2. So 9.36 times this by 2. So here, again, you can write out, if you feel that way, you can write out the zeros, but obviously as we're multiplying, we don't need to worry about this. What is most important though is we do the times everything by 2. So here there are, again, lots of different ways of approaching this one. The first thing that we could do is we could look at, so multiply everything by 2. So the first thing we could do is 2 times 0.06. Now, the way that we approach the decimal ones, the way that I usually do it without a calculator, is first of all do 2 times 6, which is equal to 12. And then notice that we're timesing this by 0.06, so instead of by 6, we need to divide this by 100. Alternatively, if that's a bit difficult for you, notice that if we times it by 0.6, we're going to move everything down by 1, so everything moves along by 1 unit. So this becomes 1.2, we move every number to the right, and then 2 times 0.06, we're going to move every number to the right again. So the 2 goes into the tenths, the 0.01, and we move 1 over to the first decimal column, so this is equal to 0.12. So again, we can put this, obviously some of you may do this really quickly, but again, so 2 times 0.06 is just 2 times 6, and then we can move the answer 2 places to the right, so we get 0.12. The next one we've got is 2 times 0.3. In this one here, we do 2 times 0.3. Again, 2 times 3 is equal to 6, and therefore if we do 2 times 0.3, we're going to move our answer 1 decimal place to the right. So this ends up being 0.6. So this is 0.60. And then finally, we've got 2 times 9. 2 times 9 is just 18, so it's going to be 18.00. From here, we add up our answer, so it's going to be 2, 6 plus 1 is 7.800, so that's 8, and then we've got the 1. So our answer is just 18.72 for our final answer. Again, please show all your working. Obviously, we're going through it slowly. You might work through this much faster. Okay, the next one we've got is question 5. 5 points are plotted on a centimetre grid. The 5 points are 5 of the vertices of a hexagon. Each side of the hexagon has the same length. Work out one possible pair of coordinates of the other vertex. So in this situation, the points of 5 of the vertices, possible pair of the coordinates of the other vertex. So in this one here, the first one we've got is going to be, here is a hexagon. So the hexagon is a 6-sided shape. So currently we have this point to this point, this point to this point, this point to this point, and this point to this point. So we're looking for a point that makes it into a hexagon, into a 6-sided shape. So it's going to be somewhere in the middle between these 2 points here to draw our first one. So for that one, we could have the point, it's going to be halfway in the middle, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So the midpoint is going to be at the 4, the fourth one along, so 1, 2, 3, 4. So it's going to be somewhere along this line here, okay? Y equals 5. And now we've got to find the positions of where the hexagon could be. So each side of the hexagon has the same length. So one possible pair of coordinates of the other vertex that we can have Well, we need to find the point that's exactly the same, that has the same length. So here, if we look at, we're obviously going to go in like these sides here. Oops, let me get my other pen. So like these sides here, those sides will come in. So we're going to do a very similar thing. And if we follow what this does, this comes down 4 and it goes along 1, 2, 3. So we go 1, 2, 3, and then down 1, 2, 3, 4. So this point here is where we're going to meet for our hexagon. So this is going to be our first point that we're going to use, which is this point and this point. And that point is going to be at x equals 2 and y equals 5. So the coordinate we write, whenever we write coordinates, is x and then y. So that's going to be at 2, 5. Now there is a second possible coordinate. Because the length of the side, we can also go 3 units to the right instead of going 3 units to the left. So be careful when it wants, because it wants a possible pair of coordinates. That means you're going to find 2. So in this situation, we're going to go 1, 2, 3 coordinates to the right instead, and then down 1, 2, 3, 4. And again, we can do the same here. 1, 2, 3 coordinates to the right, and then 1, 2, 3, 4. So the second answer that you can have, and this is the other coordinate, remember we're looking for 2 coordinates, is this one here. So this point here gives you the second pair of coordinates. Again, they are exactly the same length because they are 3 in the horizontal axis and 4 in the vertical axis for both sides, which matches what's on the other side, which is what's happening on the right hand side here. It's just that this one is going to the right instead of to the left, but it still works out. It's still a hexagon, 1, 2, 3, 4, 5, 6. So this is still a valid point. So this point here is going to be 8 and 5. So x equals 8, y equals 5. So your coordinate is going to be 8 and 5. Actually, reading through the question, I should be careful. This is actually, you can have either one of these as answers, actually. My mistake. So don't worry too much about it. Make sure both of them, I clearly misread the question there. So it's important. One possible pair of coordinates is just 2 and 5 would do. So that you could just do that as the answer, and that was perfectly fine. And 8 and 5 is the other answer that you could have. So yeah, apologies for that. So just be wary. Obviously, don't do what I'm doing, rush through the question, take your time, but 2 and 5 is perfectly fine. Okay, question 7. Amy and Brad each have no money. Amy gives £7 to Carly. Brad gives £5 to Carly. Now they all have the same amount of money. How much money did Amy have to begin with? So Amy and Brad each have some money. Carly has no money. Now they all have the same amount of money. So if they all had the same amount of money, so Carly, she now has the same as Amy and Brad. So Carly had 0 to start with. And then she gained £7, and then she gained £5. So she started with nothing, then she had 7, and then she had 5, which is equal to 12. So Amy gave her £7. So Amy ends up with £12. She gave away 7, so she lost £7, and this M is how much money she had to begin with. So we've created an equation here that we can now solve. We want to add 7 to both sides. So minus 7 plus 7 is 0. So M is equal to 12 plus 7, which is equal to £19. So we can get 19 in here. You can, of course, put the pence in as well, or you can just write the answer as 19. Question 8. We've got a game is played 50 times and a chart shows the winning scores. Write down the mode. So it's really important that it says, when it says write down the mode, you're going to write down not the value of the mode, which is 14, but the actual thing that is the mode. So in this situation, it's 29, the winning score of 29. So whenever it says write down the mode, you're writing down exactly what class or what the thing is that is the most common, not the value of it. So don't write 14, you need to write 29, and that's a very common mistake to do. So make sure, for example, if this was, instead of that, if this was a team, let's say London, or a city, let's say London, then you would write London down as the mode, not 14. Okay, so that is part A, and then part B, the game is played again. Use the chart to estimate the probability that the winning score is 25. So if we look at 25, we know that there's 50 times, so the probability of it being 25 is going to be 4 divided by the total number of games played, which is 4 over 50. So the probability that the one is going to be 4 over 50. Of course, some of you may have simplified this down. It never asks to simplify it down, so you don't feel like you need to. So it's not 2 over 25, 2 over 25, and you can't simplify that. Or you could write this as a percentage, which is just 8%. Okay, use the chart to estimate the probability that the winning score is 27 or more. So if we go back to the chart, so we want 27 or more, so we're going to find out all the possible times that 27 and above, and maybe once more as well, has occurred. So in this one, it occurred 8 times. In this one, it occurred 10 times. This one, 14. And this one, we're going to be careful, we're going to read that across. So that's in between 6 and 8, which must mean that that is 7. So then all we do is we add up our scores. So it's 10 plus 8 plus 14 plus 7. Again, take your time when you're adding the numbers up. Don't rush them. So here, when we do our things, we've got 8 plus 4. So 8 plus 4 is 12. And then 12 plus 7 is equal to 19. So we write 9 and then carry over the 1. Then we've got 1 plus 1 plus 1, which equals 3. So we've got 39 times that 27 or more won, and therefore our total number was 50, so our probability is going to be 39 over 50. Make sure you are showing all your workings out as well. There is another way of doing this, and that is to calculate how many games didn't win. So we notice that 26 has won 7 times and 25 won 4. So we can find out that probability, which is going to be 11 over 50, and then subtract that 11 away from 50, so 11 minus 50. 50 minus 11, sorry, is 39, and that's the alternate way you can do it. So there's more than one way to solve this. Then we look at question 9, so write down all the factors of 18. So for this type of question, how I would approach this is you have 18, and you simply write down, start from 1 and work out, so for example 1, so 1 times 18 is 18. 2, well 2 times 9 is equal to 18. We've got 3, so 3 times 6 is equal to 18. We've got 4, well there's obviously, if you're unsure, you can always long divide, so 4 divided by 18. So we know that that's going to be 4, and then carry over the 2, because 4 times 4 is 16, and we've got a remainder of 2, so then 4.5. So this is not a common factor. And again, 5, we know the 5 times table is 5, 10, 15, 20. So therefore 18 is not a factor of 5. The next one is 6, which we've actually found already with 3. So therefore we don't need to continue any further, because once we meet a number on the right hand side here, we can stop, because we found all the other factors. So the factors of 18 are 1, 2, 3, 6, 9 and 18. Don't forget 1, it's really common to forget 1. We'll always start from 1, so you know that that's always a factor. Lowest common multiple. So the best way to do lowest common multiple, there's lots of different ways to do this one. You can go through and you can find by going through the different tables. So 12 times table is 12, 24, 36, 48 and 60. and then 15 is 15, 30, 45 and 60. So we can find that both these two have 60. So as their first time that they meet each other, that's the lowest number where both 12 and 15 will divide and get a result. So 60 divided by 12 is equal to 5, and 60 divided by 15 will give 4. So that's the lowest common multiple. The other way of doing it is to look at the prime factors. So 12 is equal to 4 times 3. So if you do the prime factor tree, and this one is a bit more useful for like really complicated ones. So for example, if you had like lowest common multiple between 16 and 22 or something, so something that's not easy to work out the times tables. So you can do 12, which is 4 times 3, and then 4, which is 2 and 2. So this is the factor tree. So 12 is equal to 2 times 2 times 3. And then 15 is equal to 5 times 3, which can't be split up any further. So 15 is equal to 5 times 3. And if you were to put this together, it's going to be 2 times 2 times 3 times 5 times 3, which will give you your lowest common one. So 5, which is another way of finding it. So 2 times 2 is 4 times 3, which is equal to 12. 12 times 5 is equal to 60. Actually, you wouldn't have the 3 here because the 3 is seen as a both common, so you would actually ignore that one, and you get your answer, which is 60. Okay, so that is the 9b. Question 10. Coaches can take people to a festival. Each coach can take 50 people. From one city there are 820 people. How many coaches are needed? So there's lots of ways. The longest way is obviously to do trial and error and put in different values, but calculate how many coaches you need. The other way is obviously to do long division. So we have 820 divided by 50. So 8 divided by 50 doesn't work. So we move this on to 82. 82 divided by 50, well, only one. Remember the 50 times table, so 50, 100, so only one works there. And then 82 minus 50 is equal to, well, 2 minus 0 is 2, and 8 minus 5 is equal to 3. So we're left over with a remainder of 320. And then to calculate how much 320 divided by 50 is, we just continue through the 50 times table. Okay, so that's 1, 2, 3, 4, 5, 6, and the next one is 350. So 320 is going to be 16.00. So here 300 is obviously 650 divided by 300 divided by 50, which gives you 6, remainder 20, because we've got 20 left, and then this is not 0.0, sorry. Then we do 200 divided by 50, which is just equal to 4. So we can see that we need 16.4 coaches, but you can't have 0.4 of a coach, and because you need to take all the people, we need to round it upwards to take the remaining people on board. So therefore we need 16 plus 1, which is 17 coaches altogether. Again, you can do this through trial and error as well to work out how many you need. Okay, from a different city, 13 coaches are needed, and each coach costs £450 to hire. Work out the total cost of hiring 13 coaches. So this is just a simple multiplication problem. It's 450 times 13. So it's the price of one coach times how many coaches you need, and then we just go through and do some long multiplication. So 3 times 0 is 0. 3 times 5 is 15, but we start from a high position because we've got the 0. So we plug in the 0 from here, and then we do 3 times 5. So that's going to be 50 times 3, which is 150. And then we do 3 times 4, but remember we're starting from the hundredths column, so we 0, 0, and then we do 3 times 4, which is 12. So that's 1,200. For the next one we do, we've got 10 times 0, which is 0. We then do 10 times 5, but notice that we are first of all starting from 10, so we add a 0, and then we're starting with the second value, so we add a 0 here, and we end up with 10 times 50, or 1 times 5 here, which is 500. And then the final one we've got is 10 times 400, or 10 times 4 here, so this is going to be 1, 2, 3 zeros, and then 1 times 4, which is 4. Or alternatively, you could do 10 times 400, which is 4,000. Add up all the columns, so the first one is 0, the second one is 5, then 5 plus 2 is 7, plus 1 is 8, 4 plus 1 is 5. So the total cost is going to be £5,850. Question 11. On the diagram grid below, show how you can make a parallelogram with two of these triangles. So you've got a triangle here, and it's important you get the dimensions correct. It's got one side of 2 and another side of 3. And it's a right angled triangle. So you need to make sure that you use this correct triangle. For this one, there are lots of different options for you to do. If you're struggling to remember what a parallelogram looks like, it is simply a four-sided shape, and you can have a multiple of different ones. So the first one we've got is we can have a triangle that looks like this. So 1, 2, 3, 2 and along, and then we could put a triangle that's been flipped over. So we could have 1, 2, and then 1, 2, 3, and then a side that looks like that. So essentially it's back to back, and that gives a perfect parallelogram. You could also have the following one. So you could have a triangle with a base here, so it's 1, 2, and then 1, 2, 3, like that, and then you could put another triangle here, 1, 2, 3, 4. This would count as a parallelogram. And then a third option that you could have is you could have, this one might overlap, but 1, so across here, so 1, 2, 3, 1, 2, sorry that's a bit of a dodgy one, and then you can have 1, 2, 3, 1, 2, and then one that goes like that. Sorry, it's like the page, but you could have any number of these shapes for a parallelogram. So it's really important that you know what your parallelograms look like, but generally a four-sided shape with equal sides for at least two of them, like a parallel. So the parallel sides opposite are equal to have an equal length. So this one, 1 and 1, they're equal, and then the tops, they're equal size. This one has equal top and bottom, and on the sides, and again here. So with this time, the next one we've got is a trapezium. So remember, for a trapezium, one of your sides is going to be bigger than the other, and you can use 3 of the triangles to create it. So some options you might have, you might make one of the 1, 2, 3 with a triangle here. So remember, again, it's a triangle has got one side of 3 and one side of 2. So one option is to, and for a trapezium, you're trying to have something where one of the sides is greater than the other side. So it's sort of like the base is greater than the top, or obviously you could have, this would count as a parallelogram as well. So as long as one of the bottom sides is bigger than one of the top sides, if you were to invert it with that facing upwards or to the top. So here, one of the options is that we can combine 1, 2, 3. That's 1, 2. So you have this one, and then finally you can squeeze in a triangle there. So this will be a perfect use of it. All 3 triangles fit in to make a nice trapezium here. This is the top side. You can see that's far shorter than the bottom side. You can of course make a different one. So here 1, 2, 3. And then you could have the triangles 1, 2, 3 here, 1, 2, and then we could have a second one, 1, 2, at the, we made a small, let's see, 1, 2, 3. So here, just be careful. So you'll have the sides, that's 2, and then this is 1, 2, and 3, and that would lead in quite nicely to there. There we go. And then we can have another triangle that just fits on 1, 2, 3, and 1, 2. So there we go. So each of these sides, this is 2 and this is 3, this is 2 and this is 3, and this is 3 and that's 2. Again, there's lots of different ways. The final one that we've got is this one. We've got, for example, 1, 2, and then this is 1, 2, 3, like that, and then 1, 2, and then another one, and then you can have one that goes down like that as well, and that will make you another triangle for you. And then the last one, a rhombus. So a rhombus is almost like we could say like a diamond shape-esque type one. So rhombuses, for example, are like this, where all of these sides are the same. And this one, we make 4 of them, so we can see quite easily how we're going to do that. Each of the triangles can form something like this. So we have a base here of 3, height of 2. So where's one triangle, 1, 2, 3, second triangle will fit in here, and then again we can do the same at the bottom. So 1, 2, 1, 2, 3, there's another triangle, and there's another triangle. So that's an example. Or you alternatively, if I could do it in green instead, you could do the triangles outside if you were inventive, and you can make a rhombus shape in the middle. Something like this is perfectly fine as well. So you can have inside or outside, and they both make a rhombus shape. Okay, the next question we've got is a percentage question. So work out 65% of 300. So without a calculator, this one's a bit of a challenging question. There are multiple ways of doing this type of question. One of the ways to do it is well, there's 2 main ways that I would do it. The first one is to find 1% of 300. So to find 1%, we do 300 divided by 100, which equals 3. So this is 1%. So if you ever wanted to find 1% of something, if you did 100 divided by 100 is 1. So that's where we get the 1% from. So 300 divided by 100 is 3. And then to find 65%, that's equal to 1 times 65. So we know what 1% is. That's 3. So it's going to be 3 times 65. And again, don't be afraid to use long multiplication, sorry. So 5 times 3 is 15. And then we've got 3 times 6, but it's 60 times 3 actually. So we add the 0, and then we do 3 times 6. So 180. So that's 5, 9, and 1. So your answer is 195. An alternative method is to divide it to find 10% instead. So 300 divided by 10 is equal to 30, and then 10 times 6.5 is equal to 65%. So we do 30 times 6.5, and again without showing the full method, but it's the same answer. 195 is what you should get. So yeah, I prefer to use the 1% method because it's a bit simpler. Well, when you do the ones, you might have to times by a decimal or something like that. But either way would get you the mark. Okay, question 13. In a game, the average score was 50 and Tom's score was 5/2 of the average. Calculate Tom's score. So 5/2 is equal to 2.5 as a decimal. If we do 5 divided by 2, it's 2.5. And again, if you're ever struggling with this one, do 5/2. Oh, sorry, my bad. Other way around. So it's 2 divided by 5. So 2 divided by 5, so we've got 2, 4, 6. So that means that 2 goes at the top. And then that has a remainder of 1. And then 10 divided by 2 is 5. So it's 2.5. So it's going to be 50 times 5/2, which is 50 times 2.5. 50 times 2.5. So the first one we've got is 50 times 0.5, which is the same as a half of 50. So 5 times 5 is 25, which is we're going to So the way that you could do this, there's actually lots of different ways to do it. You could read it off directly, so if you're comfortable just saying 50 times 0.5 is equal to 50 over 2, because of 50 times a half. Then you could just write 25 directly. If you're not sure, then you can do, well, you know that it's going to be 550, so we're going to add 1 over here, add a 0, but then we're going to subtract a 0 because we're doing 0.5. So then it just ends up being 5 times 5, which is 25. The next one we've got is 2 times 50. Again, we're going to do 0 because we're starting from this one here, so we add a 0 to compensate for that. Then 5 times 2 is 10. So 50 times 2 is 100, and that gives you 125 as an answer. So we round that. Question 14, we have a volume. Now, whenever you have these questions, first of all, the first key thing to check is check what your units are. To check, you don't need to convert to meters. We can see here that we've got centimeters cubed, so we don't need to convert at all, and we could just multiply directly in centimeters. The volume, remember the formula for the volume is equal to base times height times width. We can see that the base is 7. So this is the base. We can see that the width is 5, and we can see that height is 10. If you forget which is the base, which is the width, which is the height, it doesn't really matter for this question because you're going to plug the numbers in. It doesn't matter the order. So here, this is equal to 7 times 5 times 10. And again, if you're not comfortable with multiplying, just take it step by step. So first of all, we've got 7 times 5, so that's 35. Times that by 10 is equal to 350. And that's where your mark is, 350. Circle the shape that has a uniform cross-section. So a uniform cross-section is something that is consistent all the way through. So if we look at a cone does not have a uniform cross-section. It starts off with a circle, but then it reaches to a point. So we can see that the cross-sectional area gets smaller and smaller and smaller until it reaches a point. So it's not a cone. A sphere is an odd shape to actually draw. So essentially it's a ball, but it doesn't have necessarily a uniform cross-sectional area. If you look at the top of a ball, you can essentially see it would look something like this. Okay, so the middle part of the ball is fatter than the top of the ball. So therefore it doesn't have a uniform cross-sectional area. A cylinder does have a uniform cross-sectional area. We can see that if we looked at the top of the cylinder, we would see, and for example, you could look, if you have a pen that is not bulging, you could see all the way down that it has the same width or the same diameter all the way down. So essentially the circle part is the same all the way through. So a cylinder is correct. And just to double check, a pyramid, so for example, a square-based pyramid, again, their pyramids all end at a point, so they're the same as a cone. So your answer here is a cylinder. Okay, question 16. 16, here's a map showing points A and B. Camel wants to measure the bearing of A from B. He draws 2 lines and measures the angle between them. He says that the bearing of A from B is 100 degrees. Is this method correct? So Camel has done the classic mistake of not reading the question properly. The question states from A from B. So if it says from B, that's where you're going to start from. You're not going to start from A. So if you measure it from B, you're measuring the bearing to A. Okay? Now, for bearings, you always start from north, which is 0 degrees, and you measure all the way round clockwise. You only measure clockwise. Okay? So the bearing of B will be massive. It's going to be much greater than 100 degrees, as you can see, because this is at 180 and this is at 270. So the bearing of B is really, really big. Now, you don't have to find the bearing in this answer. So here you could just mention, for example, that he has done B from A. Okay, so he's measured from the wrong point. Okay, so the north line should be from B is another one. If you wanted to find what the value is, Well, we know that the angle here is 100 degrees, so we know that this angle, and we know that parallel lines, if we have angles like this, then this bit, these two angles must add up to 180, so this is 80 degrees. So to find the bearing, which is this angle here, we know that a full circle is 360, so we can do 360 minus 80. 0 minus 0 is 0. 6 minus 8 doesn't give us the correct one, so we steal a 10 here, reduce that 1 to 2, and move the 10 over to 16 minus 8, which is 8, and then 2 minus 0 is 2. So the bearing is 280. However, you did not have to put the answer. Be very careful here, because it doesn't necessarily say, you don't have to waste time if it doesn't, but if it does ask for the bearing in the question, then obviously you do need to find it. Okay, so the next one, on a different map, the bearing of D from C is 45 degrees. So therefore, Nina says that D is northwest of C. So again, we want to draw this to make it clear, because bearings are quite difficult. So we're saying that the bearing of D from C, okay? So we're starting from C, and we're going to D. So this is a 45 degree angle, and it goes off like that, and then D is here. So Nina says that D is northwest of C. Well, on a compass, north, never eat shredded wheat, or naughty elephants squirt water. So we can see that C is clearly in this direction, which is northeast. So again, a correct reason would be something along the lines of it's northeast. That's it. Okay, again, you should write this on your paper, but, as nice proof, but give a reason. Make sure you explicitly state that it's in the northeast. Question C, now this is a bit difficult to do on the board because I don't have a ruler, but we can see that the map shows an airport E on an island. So a plane flies due south from the island, so south is in this direction here, so we need to go directly downwards, and you're going to measure until it reaches the sea. So this is the island, and this is the sea here. So you're going to measure this distance here. So you just get your ruler and you measure the distance. On here, I do not have a ruler necessarily. They say that the angle, it should be between 4.5 to 4.9 centimeters. From here, you use the scale, so whatever value you got, make sure you multiply it to 100 kilometers by 100, because 1 centimeter equals 100 kilometers. So for example, if you had an example being 4.5 centimeters, so here you're going to times this by 4.5, so you need to times this one by 4.5. So 100 times 4.5 is 450 kilometers. So to get the full marks of this, you need anything between 450 to 490. Even if you measure it wrong, make sure you at least show your workings out, because there's 3 marks here, and 2 of those were working out marks, i.e. drawing a line south and attempting to measure it. Okay, let's move forward. Question 17. Simplify fully 56, the ratio of 56 to 24. So here, all you're trying to do is you're trying to simplify this answer here. So 56 and 24. So again, you want to find common multiples of both of these, but you can just start basic. You can just divide them by 2 to start with, because they're even numbers. So 56 divided by 2 gives you an answer of 28, and this is 12. We can then divide this by 2 again, because they're even. Again, I'm going the long method here. We get 14 and 7, which is, wait, hang on, double checking. 28, 4, you can see that I've made a mistake here. 12 divided by 2 is obviously not 7, it's 6. And again, we can divide by 2 again to get 7 and 3. And this is your answer. So this is obviously the long method. You could divide this straight away by 8 and you'd get your answer perfectly quickly. But without a calculator, you don't need to rush this. it's an easy 2-mark question to get. So just divide through until you get two factors that can't divide. You can't find a common factor between them. The next one we've got is write down the ratio of 5 to 4 in the form n1. So this one, we start from 5 to 4 and we get to n1. So this one is quite confusing, but the way to think about it is how did this one get to 1 through multiplying or dividing, and this one divided it by 4. So here we need to do the same to the left hand side. So 5 divided by 4. So we know that 5 divided by 4 is 1 with a remainder of 1. 10 divided by 4 is 2, remainder 2. And then 20 divided by 4 is 5. So our final answer is n equals 1.25. And make sure you write it in properly, 1.25 to 1. And the next one we've got is share the ratio, share £180 in the ratio 1 to 9. So this one is quite tricky. The key thing for the ratio one is add up the ratio values, particularly if you're sharing a number between them. So 1 plus 9 is equal to 10. And then divide through that divide the answer you're looking to share by 10. So 180 divided by 10 is equal to 18. And this is equivalent to 1 part. Okay? So here we've got 18.9 times 18, because that's going to be our second one. So here we just need to do 9 times 18. And again, as I keep saying, use long multiplication. So we know that 8 times 9 is going to equal 72, and then 9 times 10 is 90, so then 2 plus 0 is equal to 2, and 9 plus 7 is 6, remainder 1. So this is equal to 18 and 162. Again, don't simplify it, so it should be 18 and 162. And that is question 17. Question 18. Here is some data about people listening to a radio station in one day. Compare the data for people aged 40 or under with the data aged 41 or over. So there's 3 comparisons and there's 3 columns. So you're just going to make a comparison for each. Okay. So the first one is that, look at your percentage one. A higher percentage of over 41s listen to the radio station than under 41s, or 40 and under. Be specific, so under 41. Obviously, you can write it much neater, but again, all you're doing is just comparing the 2 values. The next one is the mean number of average listening times. So, 41 and over had a higher mean listening time or higher average listening time than under 41. And then the final one, the range of number of listening hours, A 41 and over had a higher range of listening times. And this is compared to 40 under. Okay, so it's really important that you're explicit. Easy 3 marks. That wasn't the easiest in exams. You're just reading the exam here. Okay, so yeah, make sure that you obviously compare the 2 columns and get the 3 marks. Really easy to see. You'll always look for the marks as well, but it says clearly here 3 comparisons, 3 columns. That should be straightforward. Okay, let's move on. Question 19, some algebra. We've got given that 4a minus 2b equals 10. Write down the value of 2a minus b. So here we can say that that to go from 4a to 2a, you divide by 2, and to go from 2b to minus b, you divide by 2. Which means that this value, if you divided this one by 2 and this one by 2, you're also going to divide by 2. So 10 over 2 is equal to 5. And that's your final answer for this one. The next one we've got is write down the value of 2b minus 4a. Okay, so this one, we can see here that we have 4a minus 2b equals 10. So if you're always confused, look back at your original statement. We can rearrange this one. We can add 2b, so we get 4a equals 10 plus 2b. And then we can move the 10 over to the left-hand side. So 4a minus 10 equals 2b. So again, to move it over, we add 2b to both sides. Oh, sorry, my mistake. So here we add 2b and add 2b. So we get 4a minus 2b minus 2b is 0. And then 10 plus 2b here. And then on this side, we minus 10 on both sides. So minus 10 here, minus 10 here, so we get 4a minus 10 equals 2b, and then we can minus 4a on both sides, and we can see that we get minus 10 equals 2b minus 4a, which is exactly 2b minus 4a, so the value is equal to minus 10. Again, you could have seen that as well by timesing this by minus 1, times this by minus 1, so therefore this one must be times by minus 1. Okay, so we're given that 4a minus 2b equals 10 and a plus c is equal to 3. Write an expression in a, b, c that is equal to 23, giving your answer in the simplest form. Okay, so we're given 4a minus 2b equals 10. So the first step that we are going to do is, okay, so we want to make 23. So one way we can do that is we can say, well, we've got 10 here and we've got 3 here. So if we do 2 times this one, that takes us up to 20. So 2 times 10 is 20. Then we could just add the 3 on here. So that would take us to 23. So we can do 2 times 10 plus 3. Now we know that 10 is equal to 4a minus 2b. So we can replace that in here. So we can say that's 2 times 4a minus 2b. And we know that 3 is equal to a plus c. So then we can add a plus c. From here we could do 2 times 4, which is equal to 8a, minus 2 times 2 minus 2b is 4b, plus a plus c, and 8a, so then we take each thing, so it's going to be 8a plus a minus 4b plus c. 8a plus a is 9a minus 4b plus c. And that gives us our final an answer that we would have, which is 9a minus 4b plus c. There are other answers that you can have. An alternate answer is 7a plus 2b plus 11c. That will also work as well to get your answer. So there's multiple ways of doing this one. Okay, that's question 19. Question 20. Write 0.00097 in standard form. So here in standard form is always a number, so n times 10 to the plus or minus whatever it is. So it's instead of writing it out as a decimal. So if you're going this way, then it's going to be times 10 to the minus something. So this is minus 1, this is minus 2, this is minus 3, and this is minus 4. So we're going to start with the 9, and anything after the 9 is a decimal. So it's 9.7 times 10, and we've inserted it as minus 4. So your answer is 9.7 times 10 to the minus 4. The next one we've got is 3 times 10 to the 5 divided by 4 times 10 to the 3. So this one that we have here, there are multiple ways of doing this. The first step that I find is to try and reduce the tens as much as you can. So 10 to the 5 over 10 to the 3 is equal to 10 to the 2. So this ends up being 3 times 10 to the 2 divided by 4. And therefore you end up with 3 times 10 to the 2. So again, this is going to be, so if you start from here, this is 3. 3 times 10 is equal to 30. And 3 times 10 to the 2 is equal to 3 times 10 to 100, which is 300. So this ends up being 300 over 4. Remember, you're moving 1, 2 places. This tells you which direction you're moving in, how many places you're going to move the 3. So here we move 1, here we move 2. So that's 3 times 10 to the 2. And then we've got 300 divided by 4. Again, if you're not sure, you can just plug it in here. So 3 divided by 4 is 0, remainder 3. 30 divided by 4, so the next one is 28. So 4, 8, 12, 16, 20, 24, and 28. So it's 1, 2, 3, 4, 5, 6, 7. So it's going to be 7, remainder 2, because we need 2 to take to 30. And then 20 divided by 4 is 1, 2, 3, 4, 5. So your answer is just going to be 75. Question 21 is a probability question. Anna plays a game of an ordinary fair dance. If she rolls a 1, she wins. If she rolls a 2 or 3, she loses. If she rolls 4, 5 or 6, she rolls again. And then in the second roll, if she rolls an odd number, she wins. And if she rolls an even number, she loses. So first of all, we need to calculate the probabilities. So in the first game, there's 6 possibilities. 1, 2, 3, 4, 5, 6. In the first one, to win, there's only one possibility, which is 1. So the probability must be 1 over 6. In the second one, there are 2 possibilities. So this is 2 over 6, which we can simplify to a third, but you can leave it in this case as 2 over 6. You don't need to simplify, because it doesn't ask to simplify, but 2 over 6. The last one is a half, and you can check your probabilities by adding these up. So a half plus 2 over 6 plus 1 over 6 is equal to 1. That's fantastic. That's exactly, each of these must equal 1. Then in the second roll, if she rolls an odd number, she wins. So the odd numbers are 1, 3, and 5, and the even numbers are 2, 4, and 6. So you can see that there's 6 possibilities altogether. 3 of them are even, an odd, and 3 of them are even. So 3 over 6 and 3 over 6, which again is a half as well. So you can have a half here. And that's it. So just find out all your total possibilities. That's your bottom number. And then find out the number of successes. So what matches your criteria. So here, 1. And then that's your value. So 1 over 6. And then here there's 2 possibilities. So 2 over 6. And then the other 2 is 3 over 6 and 3 over 6. Because you've got 1, 3, 5 or 2, 4, 6. Okay, is Anna more likely to win or to lose? So for this one, you need to find out the probabilities. So let's have a look at the possibility that she loses. So if she loses, it's going to be 1 over 6, 2 over 6, because she... Oh no, sorry, I need to read the question properly. So just be careful with this one. So 1 over 6, she wins, that's a tick. 2 over 6, she loses. And then if she gets an odd number, she wins. If she gets an even number, she loses. So we can find out the probability of this one. So for example, the probability of winning is 1 over 6. So probability of a win is equal to 1 over 6 plus. Now here, when you have 2 possibilities, so when you have one probability and then another event happens for you to win, you need to multiply them. So it's going to be a half times a half, or times 3 over 6. So this is equal to a half times a half. And this one we can do, so a half times a half is equal to 1 times 1 over 2 times 2, which is 1 over 4. And then we've got 1 over 6 plus 1 over 4. The common multiple of this one, lowest common multiple is 12. So that's equal to 2 over 12 plus 3 over 12. That's equal to 5 over 12. Now, here the probability of winning is equal to 5 over 12. Now, we can find out what the other probability is, because we can do 1 minus 5 over 12. which is, to find this one, we could do 12 over 12 minus 5 over 12, which is equal to 7 over 12. So the probability of losing is equal to 7 over 12. So therefore, you can find out the probability is more likely to lose. Again, you could have done it with a different method. You could have done it to find the probability of losing instead, and then subtracted that away. Both ways are perfectly fine. 21b. Let's move on to 22. So 3 friends arrive at a party. Their arrival increases the number of people at the party by 20%. In total, how many people are now at the party? So essentially, it increases your value by 20%. So essentially, 20% is equal to 3 from the original value. So you've got to think this is the original value. So originally, there were 20% of people are at the party. So we can find out how many people were originally there. So 100%. This is the original values. Because 3 people increases the number of people by 20%. That suggests that 3 is equal to 20% of the original people. So 100% is simply going from 20 to 100 is timesing by 5. So 3 times 5 is equal to 15. So 15 is the original one, and then we add 3 because these extra 3 people arrive, and that takes us to 18, which is our final answer. Again, there's lots of different ways of solving this one, but you could do 3 times 6, for example. You could say 1.2 is equal to x plus 3, and then solve it that way. 1.2x, is equal to x plus 3, and then you could have said, well, and solve it again. But I mean, this way is quite a nice, easy way to go through, because it's a bit simpler, you don't need to use algebra. Question 23, so here, work out the value of 3 divided by 12, 3 to the power of 12 divided by 3 to the power of 5 divided by 3 squared times 3. So here, individually do this. So this is 3 over 12 divided by 3 to the power of 5. Use your indices rules, so a to the power of b over a to the power of c is equal to a to the power of b minus c. So here this is 3, 12 minus 5, which is equal to 3 to the power of 7. And then you've got 3 squared times 3, which is equal to 3 squared times 3 to the power of 1. And again, a to the power of b times a to the power of c is equal to a b plus c. So you add the powers, so this is 3 cubed. And then you combine it, so you're dividing both of these, so it's going to be 3 to the power of 7 divided by 3 to the power of 3, and using this rule here, which is 7 minus 3 is equal to 3 to the power of 4. And then from here it wants to find a value, so you need to make sure that you get a value. So 3 times 3 is equal to 9. That's 3 squared. 3 cubed is 9 times 3, which is 27. And 3 to the power of 4 is 27 times 3. Again, if you're unsure, please use the long multiplication. 7 times 3 is 21. And then 3 times 60 is 3 times 20 is 60. So this is 1. This is 81 as an answer. But please, just take it step by step. Remember to do the brackets first as well, as for BIDMAS or BODMAS. That's why we did the 3 squared times 3 first before we divided through by everything. The next one we've got is a plus b is equal to 0. So here we can rearrange to find b. If we subtract b, we want to find equal to b, so we want b by itself. So we need to move a to the other side. So if we minus a from both sides, a minus a is 0, so we're just left with b on the left hand side, and 0 minus a is just minus a. So therefore b is equal to minus a, which gives you your answer here. And then we've got c times d is equal to 1, which of these is equal to d. So we need to get d by itself, so we're going to divide both sides by c, because that's the opposite operation to multiplication. So d is equal to 1 over c. Okay, question 25. We are given a shaded semicircle is inside a circle as shown below. The radius of the circle is 10 centimeters, the diameter of the semicircle is 8 centimeters. How many times bigger is the unshaded area than the shaded area? So the first thing we need to use is the area of the circle is equal to pi r squared. So this is for a circle, and for a semicircle, that's half a circle, so that's going to be a half pi r squared. So this is for a semicircle. So if we do the circle and we plug it in, the circle is going to be pi times 10 squared. Remember, the radius is the point from the middle to the side, it's not the full length. So this is equal to 100 pi. The semicircle, remember this is the diameter, so we need to half. So the diameter is equal to 2 times the radius. So therefore diameter over 2 is equal to the radius. Remember, the diameter covers the whole shape. So here we need to do 8 divided by 2, which is equal to 4, and then plug it into the semicircle one. So the semi is equal to a half pi times 4 squared. This is a half times 16 pi, which is equal to 8 pi. And then we want to see how many times bigger it is. So simply we're just going to take the biggest value, which is 100 pi, and divide that by 8 pi. 100 pi divided by 8 pi cancels the pi's, and therefore we're just left with 100 divided by 8. So 1 divided by 8 is 0, remainder 1. 10 divided by 8 is going to equal 1, remainder 2. Then we've got 8, 16, 24, so 20 divided by 8 is 2, remainder 4. So it's going to equal 2, remainder 4. So here we then, this one's 8, 24, 32 and 40, so this is going to be 12.5. So how many times bigger is this one going to be? So the answer here, you need to be careful here. So this is 100, so this is 12.5. So the answer here is going to be 12.5 minus 1 to find out how many times bigger it is, because it's already got 1 times here. So it's going to be 11.5. So just make sure that you reduce it by 1 to get your answer here, which is 11. So it's 11.5 times bigger. It's not 12.5 times bigger, it's 11.5 times bigger. And the reason why it's 11.5 times bigger is because the shaded region is already filling up the space here. So it's a bit of a trick question to get that last one. Remember, the shaded region is inside the unshaded region. So even though that the area itself is 12.5 times bigger, one of those areas is taken up by the shape that's inside the shaded region. So therefore the 11.5 part is 11.5 times bigger, simply because we've removed the 1 from the fact that we've got one of those diameters inside the area. If it was outside the area, so if it was like this, and then you had an unshaded region, this would be 12.5 times bigger. But as it's inside, you remove one of the areas away, so that's why it's 11.5 times bigger. Okay, question 26. Question 26, we have the number of items made in 1 hour by a machine is n equals 60 over t. T is the time in minutes the machine takes to make one item. The value of t changes for different types of item. On a grid below, draw the graph of n equals 60 over t for values between 1 and 4. Okay, what we need to do is you do a grid. T here, so we know it's 1, 2, 3 and 4, and then we have n. So then we just plug in the numbers. So t equals 1. So n divided by 1 is equal to 60. So there's your first value. Then we do 60 and then t equals 2. So again, remember, we're just using this formula here. 60 divided by 2 is 30. Then we do 60 divided by 3. 60 divided by 3 is 20. And then we do 60 divided by 4. 60 divided by 4. So now, again, you just need a quick reminder. 6 divided by 4 is 1, remainder 2, and then 4, so it's going to be 15 as your answer here. And then you just plot the points. On your graph, draw the values. So you're going to have 1 is 60, 2 is at 30, 3 is at 20, and 4 is at 15. And then you would draw, it's going to be a bit difficult for me to draw it perfectly, but you get an answer that gives something like that. The next one we've got is use your graph to estimate a value of n. So here it's going to be 3 minutes and 30 seconds. So first thing is first make sure you convert this properly into minutes. So 30 seconds is half a minute, so this is 3.5 minutes. Then you go to your graph, you find the halfway point here, so this is 1, 2, 3, 4, 5. So it's going to be, there's 5 points between 3 and 4, so the halfway point is going to be at 2.5. So get a ruler, draw at the point 2.5, and you reach the graph, and then from here, draw it across to the y-axis to find a value at that point. So you will be given some leeway here. So this is 10, 1, 2, 3, 4, 5. So there's 5 points here, so each one is worth 2. So it's going to be somewhere between 16 and 18. So we're going to say here that this is equal to 17. But again, it's very, very close here for what you need. So the value of n here is equal to something like 17 is perfectly fine. Okay, let's move forward. The last two questions then is x equals 2y minus 6. So we need to rearrange to make y the subject. So here the first thing we do is want to make y by itself, so we need to get rid of this minus 6. So we move minus 6 to the other side by adding 6 to both sides. So this is x plus 6 equals 2y. Then we've got 2 times y here, so we divide both sides by 2. X plus 6 divided by 2 is equal to y. And that's your final answer here. We've got y by itself. This is the subject of the equation. And the last one we have is multiply and simplify x plus 5 and x plus minus 1. When you multiply brackets, you do each term, so it's x times x first, so that's x squared. Then the second term we do is x times negative 1, so x times minus 1 is minus x. Then the next term we do is 5, so we do 5 times x, which is plus 5x. Then the final one we do is 5 times minus 1, which is equal to minus 5. So our final answer is x squared. Then we add these terms, so 5x minus x, which is plus 4x. Then we have minus 5. So we have x squared plus 4x minus 5. And that brings the end of the paper and the final question that we have. Any questions?